Hi there, welcome back to the second video of our core it's calculator, this one, the core calculator paper for common entrance. We're on to question 10. I've got the screen fired up, ready to go. So on the centimetre grid, rectangle A is enlarged onto rectangle B from the centre of P. What is the scale factor of the enlargement? So we'll take this part here, it's got a height of 2. 1, 2, 3, 4 has that height for part B. So 2 times by 2 gives us 4, so it's a scale factor of 2. Not a lot needed to be done there. Write down the perimeter of rectangle B. So it's got a height of 4. The width is 6. So that's going to be 4 plus 4 plus 6 plus 6, which is 20. And then it's on a centimetre grid. So that will be 20 centimetres. And I think that's where that second mark will come from. Another enlargement maps a square X onto square Y with a scale factor of 5. So X onto square y, so x times by 5 will equal y. The area of y is 100 centimetres squared. So what is the perimeter of x? Well, first of all, we're going to work out the area of x. It says it's a square, so that keeps things easy. And it was multiplied by 5 as a scale factor, and this is something that you hopefully will have been taught. Because the enlargement, we're now talking about the area of it, it's going to be a squared scale factor. So x times by 25 will equal 100. Therefore, x equals 4. Now, let me just get all of this correct. That's the area of that shape, of shape x. And therefore, it's going to be a 2 by 2 square. So because it's 2 by 2, we've got 2, 2, 2, and 2, making that perimeter 8 centimetres. Okay, question 11. Messed this up when I drew it because I went off the grid a little bit, so I'm going to try and stay down there. So it's make an isometric drawing, 6 by 3 by 5. So it doesn't matter what way we do it. So that's 3. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6. So 3, 5, and 6. You can do this in any way you want to. I just now need to keep the dimensions consistent. So that's 5 and that's 3. 1, 2, 3, 4, 5. 1, 2, 3. There we go. Super. Okay, calculate the volume of the cuboid. Nice and simple. 6 times 3 times 5. Remember to always write down your working. That gives us 90. And then our units are centimetres cubed. All right, question C. A small L-shaped block shown below is made from 3 1 centimetre cubes. How many of the L-shaped blocks will fit together to fill the cuboid? So if we do fit them together, we should make a little square like that. So that'll be 2 of them. And it's got a base of 2 for that width. And because we've stacked them on top, that's 2 and 1. So they're going to be 3 by 2 squares. And then if we look at the base of it, I'm going to change the colour of my pen to... I did not change the colour of my pen like I said I was going to. Please work. 1, 2, like that. Like that. Like that. So we can fit 3 of them, and they're going to go up to that bit there. So there's 5 rows. So 3 times by 5 gives us 15. And then we need to double that because that's 15 lots of this formation, and there's 2 of these in that formation, which gives us 30 blocks. You can tell now the questions are getting slightly more difficult as we go through. Okay, forgive me for this one. This is going to look absolutely terrible, but lines of symmetry, 1 down the middle, 1 through there, 1 through there. I've almost bisected it. Of course, you can do this much neater with your rulers and pencils. There's my 2 attempts for that. Okay, a shape has 1 line of symmetry from the list below. Circle. So an isosceles triangle has like that line there, so that's fine. Rectangle's got 2. Can't do that. Parallelogram, I think only has any, does it? Because it's like that. So if you were to do one like that, it would be... So parallelogram has nothing. The kite has one. Oh, that's not a kite. Oh, and I've dropped my pen. So, of course, let me draw a proper kite. Like that. That line of symmetry just goes down that bit there, and then for the semicircle, that's the line. So we've got 3. Question 13. Rose drives 504 miles in exactly 9 hours. Calculate her speed. So speed, distance, and time. We want to know the speed, which means we do distance divided by time. 504 divided by 9, 56 miles per hour. Now, Cameron drives at a mean speed. That means an average, like the average speed. It doesn't mean, oh, it's a mean speed. He's a mean driver. 64 kilometers per hour. And they want to work out the distance he travels. So that's going to be speed multiplied by time. However, it's not 64 times by 4.15. 15 minutes is a quarter of an hour, making it 0.25 if we convert it to a decimal. Therefore, it's multiplied by 4.25, and it gives us 272 kilometers. All right, question C. Quite a cool one, this. So a bullet is fired in space at a speed of 1250 meters per second. So because it's been fired into space, that means there's nothing that's going to stop it from decelerating. It's not going to change from its speed. Calculate the time it takes to reach a target 8.75 meters away. So that's wrong, 8.75 kilometers, which means I need to turn that into meters, which is 8,750. We're looking for time, which means that it's distance divided by speed. So 8750 divided by 1250 gives us 7, and that'll be 7 seconds. Please do use that formula triangle because it does make things really easy when you're trying to work out what calculations do, whether it's multiply or divide. Okay, just want to use my mouse. If it works, here we go, just do a time check. So slow, don't know what my computer's doing. I think I might, I'm going to stop it here. We'll do a third video where we'll finish off the paper, and I'll see you next time.